Hi, I'm Paul Beckwith. I'm with the Laboratory for Paleoclimatology at the University of Ottawa. I'm going to talk about an interesting phenomena that's just occurred on the west coast of the U.S. and it's very puzzling. I'm not sure really what it involves. I'm speaking to my Geography 3321 class, Geographical Approaches to Environmental Issues. So this is so what I've got here is this is Earth Null School. Probably lots of you will recognize it. If you just click down here on Earth, you bring up a menu, and you can see this is looking at the wind and carbon monoxide concentration at the surface. So it's under mode is chemicals, CO2, carbon monoxide, CO2, SO2. Those are the three things that we'll look at. And if you just click back on Earth again, then this closes down. So 93 parts per billion by volume. That's what we're seeing here. Now you can see some high concentrations here. So if you just click on this, you can see 893. So you can see something going on off the coast here of the U.S. Okay, well this is where the CO is, and it's also over in the industrial centers. You get carbon monoxide when there's incomplete combustion of fossil fuels. So if your car is not tuned up well, when the gasoline is burning, you'll get more CO produced. The catalytic converter is supposed to get rid of it. But the other thing here is you'll notice this gives you the time and the date. So this is O2. This is February 25th at 1600, and I can advance this along once here and close this off. And look what's happened now. So within the space of 3 hours, we got a massive burst of carbon monoxide. And I can click on this, you can see it's over 1,000, and you can see this dark area, 2468. And this is over a vast area of California. So what's going on there? It's too bad I can't, I guess I can, does this work, I wonder? It should do a movie, but it's not doing a movie. Okay, well I'll advance another 3 hours and close it down. Look at the difference now. It's too bad I couldn't advance it and you could see that, but anyway, that's late. So I'll advance it a few more times. Every time I advance it, it's 3 hour time steps. Okay, so what's going on here? Now, of course, you can expand and look at that region in more detail, which we'll do. So this is an ugly mess. Okay, this is weird, this is unusual. Look, it's coming out from all different areas of California. Okay, so my working hypothesis is that a lot of these areas are along the San Andreas Fault. So it's coming from land. It's carbon monoxide, CO, at high concentrations. There's even some down here, and the San Andreas Fault, the fault lines in California run right up the coast here. So I think there's been a shift on the fault line. This is speculation, hypothesis. It just happened. It happened February 25th it started coming out, the gases, between 1600 and 1900 local time. And we'll proceed further on. What other gases are there? Okay, it's not just CO. CO2 is also coming up. Okay, so let's go back to February 25th at 1600, if we can get close to there, 1430. Okay, so 1430, what was the next one? 1730. Okay, so we go to 1430 local time. This is what the CO2 looks like. So there is some CO2, but it's more offshore, right? Same here, it's offshore. And now if we go here and we advance 3 hours in time, okay, look what's happening here. Okay, we're starting to get CO2 coming out too. And this is in a line. This is exactly where the faults go up the coast of California. Let's advance a bit more. Here, are there any geologists here in the audience? Look at this 3 hours later. We'll just advance. It's annoying that I can't have this window smaller. Advance 3 more hours. Okay, and it comes out more and more and more. what else can we tell from this? SO2, sulfur dioxide. If there's volcanic activity or emissions from the ground, we expect high SO2 as well. So we'll go back to the original time here, 225.16. Okay, so this is sulfur dioxide. So sulfur dioxide is also emitted from industrial processes. It's also emitted from combustion because there's sulfur in a lot of coal. Burn the coal, you get sulfur dioxide. Get a lot coming out of the smokestacks of power plants. If we put it up into the upper atmosphere, we could cool the planet, right? We're putting tons of it in the lower atmosphere. Yeah, if we talk about the idea, oh, you know, geoengineering, scary stuff, let's put some into the stratosphere, you know, everybody gets scared and nobody complains about this stuff, but it's there. So you can see the concentrations of SO2. Micrograms per cubic meter is the unit. But the key is, let's have a look. So this is at February 25th, 1600. I'll advance 3 hours. Look at that. Let's go another 3 hours. Okay, there's another 3 hours. It's starting to look ugly. Go another 3 hours. Okay, this is satellite data. Nothing wrong with the sensor. It's working well on the rest of the planet, right? This stuff's being released all up the fault line. Now, if you want to advance a full day, so this one looks the ugliest. So let's, if you want to advance a full day, then you can click these double arrows or back. So we'll go back to before the event. So this is before the event, okay? So this is just, like this just happened a few days ago, right? And if I go a full day ahead, this is what you get. And if I go another full day ahead, this is what you get. Okay, so it looks like it's starting to dissipate. What day is this? Is 2 full days after the initial event. This is the 27th at 4 o'clock. So yeah, it's almost 2 full days ahead of the event. And it's starting to get thinner in here in these regions. It's starting to dissipate. So it was coming out in a big burst within 3 hours, somewhere within that 3 hours. And then it was very strong and coming out strongly for at least a day, maybe 2 days, and then now it's starting to dissipate. So let's go forward another day here to the 28th and close this here. Okay, so now it's starting to reduce, and if I go one more, it's starting to reduce. So the event is over, whatever it was, the emissions from the Earth, what else can it be? And now it's going back to normal. So what happened is we had some fracturing in the San Andreas Fault, I would argue, and it released a big burst of gas. Now, we don't know much about, we can't predict earthquakes ahead of time, but there has been a case where somebody did monitor gases coming out, and I think that they monitored gases coming out, and then there was, not in California, but somewhere else, I don't remember where, and then there was a 7.9 earthquake shortly after. So if I was in California right now, I might be getting a bit nervous. People are asking me what's going on. It's one of the reasons I wanted to get this video out. So let's have a look. Let's go back and look at the, let's see what else is happening. We'll go back to just before the event. And we'll go to the carbon CO again. And let's try to look at some of the levels. So this is before the event, right? And this is about a day later. It was coming out pretty intently. Okay, so it's a black mess there. So let's go up. Let's zoom a bit more, just with the mouse slider. That's the most I can get. So what levels are we talking about? 16,447 parts per billion. Now, I don't know the levels where you asphyxiate, you know, but people will definitely be getting headaches and stuff. The thing is this is, you know, CO is lighter than air. Like nitrogen is N2. Air is mostly nitrogen, right? N2, which is a molecular weight of 30. It's also CO2, which is a molecular weight of, well, CO2 is a trace gas. It's also oxygen, O2, which is a 32 molecular weight. So that's about the molecular weight of air. CO is going to be about 30, about the same too. So it's you know, so it's pretty like it's going to be mixing. It's not, you know, it's coming out from the surface. It's going to be in the air, and it's not going to be taking off. Like, it's not super light. So you know, I haven't heard of any health reports yet from these regions, but you know, if you look at the levels, you know, what's the normal level? Well, let's go out here, 130 parts per billion. Okay, CO, that's pretty, 143, 130, so about 100, it's higher there. Well, I clicked on a light spot. You know, if there's industry, it's going to be coming out where all the major cities are, like up on the East Coast, right? But out in the ocean here, a bit lower, a bit higher, well, about that number. So, you know, we're talking about, you know, enormous levels. These numbers have gone as high as 40,000. Okay, I saw somebody who found a spot that's 40,000 on a particular day. So what about CO2? Because we all, you know, we're all familiar with CO2, right? So over here, 400 ppm, right? This number, the average now is about 406 at Mauna Loa, which is really high. This stuff, CO2 is like taking off. It's exponentially rising. I mean, we're supposed to have cut emissions and, you know, had negative, like, level world global emissions, but we're still getting levels in the atmosphere. The danger is that we lower our human emissions right down, and emissions still take off, or CO2 in the atmosphere still takes off. That means it's coming out of the Earth system. You know, that means it's like panic time. We have to start removing it from the atmosphere. How am I for time? Okay. 3 minutes? Okay. Okay, just thought you might have fallen asleep at the switch there. Okay, so 3 minutes, I can have a swig of coffee. So, 615, 625, you know, so the levels are, you know, they're definitely a couple hundred higher. So what I did is, I wondered, okay, you know, this is how you do science, right? Like, it's really like, you know, you just try different things and see so what else, what would you wonder? Well, hey, if there's a lot more CO2 in that region, maybe it's trapping heat. So maybe the air temperature is higher there at the surface. Air temperature, we can do total, like water also comes out of the earth, right? Water comes out of volcanoes, right? That's one of the ways we thought water went into the Earth's atmosphere when the Earth was forming. So this is total precipitable water and total cloud water. If you're not sure what it says, yeah, you can just hover over it. So maybe there's a difference in that number, but we really want temperature first. So let's see. So you can look at the temperature in this region, you know, before and after the pulse came out. And I've done that, and I couldn't see any noticeable difference in temperature. So the local CO2, you know, wasn't trapping additional heat. I mean, it could be a cloudy day or something, and it's not trapping the sunlight. The sun, there isn't heating up. What else could you look at? You could look at total precipitable water, right? And you can do this yourself. Just Google Earth Null School and play around with the menus and see what's going on. You know, email me or put a message on Facebook or whatever. Let me know if you find anything interesting. But so this is the total precipitable water. So there's 32 kilograms per square meter of water. So if it rained at this region and all the water vapor came out of the atmosphere, it would weigh 32.8 kilograms. Lots there, right? Lots over the ocean. Over here, you know, you can compare these numbers, you know, right where before and after, like go to that date where the pulse came out and look at that region, you know, leave the cursor there, look at the number before and after, like those over the 3-hour period or 6-hour period, it may have changed. So, so anyway, this is, you know, this is a very unusual event. You know, what's going on. So the next, you know, another step to do is just Google USGS, US Geological Survey. Go to their website, look at the, look and see whether there's been any large quakes or small quakes or any shift on the faults during the time when the pulse came out. You could go to local weather stations, for example, in that region, and get accurate temperature data. This data doesn't have high resolution, it's satellite data. You can go get, you know, find a region where that big pulse came out, and you can see what's going on. So anyway, I think I'll conclude there. I haven't seen a peep in mainstream media